Good morning, good afternoon, good evening, ladies and gentlemen, wherever it is you're joining us from. My name is Dr. Sandra Powers, and I'm here to bring before you today. It's a practical session, hands-on design, use case modeling design, and the domain that we are designing is the natural language processing domain. We are going to be documenting the NLP, which is the short form for natural language processing, in a use case diagram. In a previous video, I have explained what NLP is, and NLP essentially is natural language processing, which is a branch of artificial intelligence that gives machines the ability to read, to understand, and to derive meaning from human languages. Now, NLP is still a part of artificial intelligence. You can see from the Venn diagram on the left that NLP is a subset, it's inside, it's a child of, it's a type of artificial intelligence. It has relationships with machine learning and deep learning. We'll be exploring this further, but essentially natural learning language basically is the ability that machines have to be able to read, understand, and derive meanings from human languages. As humans, when we speak, we speak and we write, but machines don't speak and machines don't write naturally. Machines take what comes out of humans and understands them first of all, and then puts a layer of interpretation courtesy of machine algorithms on them, and then they're able to make a decision courtesy of the information that has come out of the translation of the human language. And so natural language processing basically is how machines process and understand human language. Machines by themselves cannot of their own volition understand human language. They need to be helped to get to the stage whereby they're able to understand the human language, read the human language, absorb the human language, imbibe the human language, ingest the human language, interpret the human language, and then therefore afterwards make a decision based on the interpretation that has come out of the human language. So the objective of natural language processing is to make computer machines as intelligent as human beings in understanding language. Basically, the ultimate goal of natural learning language is to fill the gap with how people communicate in their natural language and what the computer understands in its own language. Computers speak in ones and zeros. Computers have their own language. They don't speak English, they don't speak Spanish, they don't speak Chinese, they don't speak Arabic. They speak machine language, ones and zeros, codes. Codes are machine language, and code is the only way that you're going to be able to get the machine to be able to absorb what comes out of the human and interpret it. If it's not in code form, machines cannot deal with it. And the challenge here is that on a day by day, hour by hour, minute by minute basis, data is increasing at an alarming rate. A large portion of the text or of the data we have today is in the form of text, is in the form of emails, is in the form of logs, is in the form of reviews. Machines cannot read this. Machines cannot understand it. First of all, they need to take all of those information, pre-process it, add a layer of meaning before they are able to translate it and understand it. So I've explained all of this in a previous video. By all means, you can look through my thread and see the link. But what I'm going to be doing in this session is actually undertaking the hands-on building called use case design. Use case modeling is a skill that is invaluable to an analyst, to a consultant, to a product manager, to a product owner on a client side. Basically, use case diagrams the way is a technique for specifying the context of a system, capturing the requirement of a system. It's a way of validating systems architecture. I've been able to do this for the AI domain at 100,000 feet picture, and also been able to do this for the computer vision element of AI. Now, what I am doing in this session is actually the design and construction of the use case diagram specifically for natural language processing. Before we get to that, just very quickly, you can begin to look at some of the applications of natural learning processing, natural language processing, in fake news detection. Some of you may have experienced being on Facebook, sharing some material, a post, a news item, a news article, and being then retrospectively warned by Facebook that you are in violation of its news and posting rules, whereby a particular item has been branded as fake news. Well, how did it land to that on that decision? Was it able to compute and get to that answer? The fact that the information that you have shared, which you legitimately thought was right, correct, and of truth, how has the algorithm at the back end, as soon as you press the send button, what gave rise to Facebook now notifying you that the reason it has withdrawn or prohibited your ability to make a posting is because it has assessed that material to be fake news? What has happened there? It's the mechanics and the infrastructure at the back end, which we don't always get to see, called the natural learning language, that has made that possible. NLP can be used in predicting diseases, whereby information about treatment, about care, which can often be in the form that that humans cannot immediately make sense of, but machines will ingest this data, read this data, interpret this data, translate this data, and make a judgment call, predict a certain treatment plan, or give rise to a decision that can alter a particular course of action that has been noted for a person. NLP can be used to detect errors. NLPs can be used in IVR application. Natural language processing is also the technology behind chatbots, behind live chats, behind functional live bots, behind rich conversational chatbots, behind personal voice assistants like Alexa and Siri and Google Home Nest. There are so many applications, and the more you are able to stay with us and pick up on this learning material, the more that you are able to be all the wiser for it. So we have several videos, best of all, we are able to also enroll you in an internship program. That means that you come on board and you're able to pick up learning that is specific, that is hot to trot, that is in demand, that is trending. AI skills, not just AI skills, being in depth, being an AI solutions provider, being a core consultant, knowing your onions in AI. AI is much more than just algorithms and tools and models and formulas. There is also the necessary thinking. AI is a domain space by itself. So once you are able to understand not just the domain of reference, say financial services or government or public sector, or retail or e-commerce or automotive, you are also required as a comb-shaped employee to also be endowed as far as AI information and knowledge is concerned. And what happens is that the knowledge we're able to give you in our 10 days and 20 days internship program is one that gives you enough meat on the proposition to be good enough as far as being immersed in the language of and domain of AI is concerned, as well as giving you practical hands-on experience that you can take with you to any nation, any location, any entity, any company that is that has projects or has decided to make a foray in the digital space of today. What we are able to do is give you the necessary tools to become a valuable member of the team from day one. So by all means, reach out to me, and I'll send you details of the various groups we've set up and send you various videos, and also enroll you very quickly onto this very short, sharp sessions that make more sense than the thousands of pounds you will pay by going to one of these very expensive online or offline universities. So let's get to it. Use case diagram design specific to the natural learning language processing, NLP. So what I did earlier was that I have been able to get VISIO on board, and this is the VISIO palette, clean, brand new, shiny, and I want you to walk with me as we cut a swath through this. So on the left, it has nodes for my documents, import, new document, and also a node there for UML diagram. We go to the node for UML diagram because, of course, use cases are one of the 13 different diagrams that sit in the UML notational tool set. UML is the notational language. You know, when we speak, like when I speak to you now, I'm speaking in English. You can understand me in English. You can digest what I'm saying in English. You can interpret in English, and I'm assured that you are able to understand me clear. What UML is what the English language is. It gives developers, it gives members of the project team and development team the opportunity to speak the same language. So what UML is a collection of notational tools that allows a member of a team, a development team, a non-development team, to model static elements of the system and dynamic elements of the system. UML modeling use cases sit in the interaction modeling part, and so because where UML is use cases are all about modeling behavior, modeling responsibility, modeling relationships, so we can begin to see what the entire goals of the systems are, how it is that they are realized, who the actors are, what systems are used to realize the goal and bring to life the various goals and desires of the company. So where on the left we've scrolled down to UML diagrams. When I click on UML diagrams, something special is going to happen. Oh, this is Smart Draw. No, I don't want to use Smart Draw. I want to use VISIO. Sorry. Yeah, VISIO. Forgive me. That was Smart Draw. Also another tool for documenting, but I believe Smart Draw is much more limited. VISIO is better. VISIO is also free. You can register, go to office.live.com, and with no money paid in any way, shape, or form, you can very quickly get yourself on board and get yourself on a free plan. And so I'm now in VISIO, and I want to put together a VISIO diagram, but not just any ordinary VISIO diagram. You can see as I scroll down that there are popular diagrams, that there are basic diagrams, there's basic flowchart, cross-functional flowchart. All of this are different ways of modeling. These are all different ways of modeling. So when you go as a solutions provider, as a consultant, as a digital analyst, as an AI engineer, as a conversational design architect in a company, you are expected to come with the knowledge of how to work with tools such as VISIO. And this is part of what we do in our internship series. So when you come on board, you not only pick up on domain knowledge, you not only pick up on sector knowledge, you also also pick up on tooling knowledge. So as I scroll down, you can see all sorts of diagrams there: basic network diagrams, detailed network diagrams, AWS diagrams, Azure diagrams, crow's foot database notation, Chen's database, UML activity. So we are now in the UML section. There's UML class, UML communication diagram. All of these are different UML diagram types. As I told you earlier, there are 13 different diagrams that UML has, and use case diagrams are one of the 13. The others you can see are UML activity diagram, UML class diagrams, UML communication diagrams used to model behavior, class diagram used to model structure, activity diagram used to model interaction and behavior, UML component diagrams used to model structure, database notation used to model structure, deployment diagrams used to model structure, sequence diagrams used to model states and sequences. Developers love those particularly. State machines, oh boy, they love that. Developers love that. Sequences give you an idea of the suits of the flows from one object to the other. State machines give you the ability to model the changing states and changing events in the system. Developers love, of all the different types of UML diagrams, developers love UML state machine, but this is the one we want. Look at that, UML use case diagram, and there's 1, 2, 3, 4, 5. So the challenge is, which one do we choose? Well, I want to choose a UML diagram that has the boundary element, which is the, this square. If you go to the previous videos I've done, this square denotes the boundary of the system. This contextualizes the system. And this particular use case diagram is for the NLP, natural language processing, and I like it. I like being able to make clear what the boundary of the system is, and for readability purposes, I also support that. You can also design your use case models in other ways, but for me, I want specifically a use case diagram that has the system boundary. So this one says UML use case with subsystem. This one says UML use case for reference. I could use any one of the two. I'm going to lean towards this one, because if you look at that, it's got primary actors on the left and then secondary actors on the right. But if you looked at this one only has actors on the left, not on the right. Actors on the left are called primary actors. Actors on the right are called secondary actors. The ones on the right tend to be the systems that you need to be able to realize the use cases. So this is not optimal. It's good, but it's not optimal for me. I want to represent my system like this with my primary actors and secondary actors. So I'm going to go ahead and choose this. I've pressed create, and now we're going to create the use case diagram for the natural language processing. Okay, so if I click on that, I'm going to name that as natural language processing NLP domain use case diagram. Yeah. I could have also called it NLP UCD. But the problem with just naming it UCD is if you take this use case to somebody who is not aware of what use cases are and what the acronym means, you may end up falling flat on your face. So use case diagram is better, I feel, so that you are clear on what the terminology is. But if I was dealing with somebody who was well-versed and exposed, such as I have been in the development space, what I would tend to do is just call that the UCD. So this actor here is called student referee. For us, this actor here is called the NLP user. Yeah? I only need one actor for now, so I'm going to deliberately delete that user. So you can see that there's a line here. This is called a line of association. Other diagrams, such as the ones that I did a few days ago, the Lucy chart, had the arrowhead. But you can see that this VISIO is very respectful of the latest versions as far as UML is concerned, as far as BPMN is concerned. So in the olden days, we used to use more of the arrowheads, but this is 2020 and the association line does not have any arrowhead. But what this association line is trying to say is that this there's a relationship between this user and the use case diagram. I'm going to call this use case diagram, I'm going to call it facilitate natural language processing. Remember, I said in the previous versions that the naming convention for the use case is such that it has to be verb first. The verb is a doing word and an action word. This may well change, but for now, let's leave it as that. For now, let's leave it as that. So facilitate natural language processing. I could also put in bracket there NLP. So I've done that. And so the next thing to do now is NLP is quite a vast area. NLP is huge. And one thing about NLP is that there's a number of use cases that are also triggered. There are child use cases. And so there's so much goal to be realized in the design of an NLP system. So what I'm going to do now is begin to expose the NLP system for what it is, that you begin to see how much in terms of the application of machine learning and deeper learning. Remember those Venn diagrams where we saw that natural language processing had a relationship with machine learning and also deep learning. This here, this section here, this is our zone of interest. This here, oh forgive me, the blue and orange section, this here is our zone of interest. It's our zone. All of this, machine learning, deep learning, natural language processing, are all different types of applications of artificial intelligence. But we can also see with this Venn diagram that there's a relationship. This is called a Venn diagram. You know, when two diagrams touch together, then it's called a Venn diagram. So the machine learning relates to NLP to an extent. Deep learning also relates to NLP. Deep learning is also in its entirety a further subset of machine learning. So deep learning is it's a more applied type of machine learning. And the two of them have a relationship with natural language processing. And all of them, natural language processing, machine learning, and deep learning, are all sitting inside as children of artificial intelligence. So we can begin to see that relationship. So basically what I want to do now is I want to now document. I want to document that. I want to document that. Natural language processing, you can see that it named entity recognition sits within that. Parts of speech tagging sits within that. Syntactic parsing is a technique, it's a modeling technique, it's an algorithm technique, is one of the ways that the NLP engine builds and understands and interprets human speech. It sits in that. Text categorization sits inside natural language processing. Co-reference resolution sits within that. Machine translation sits within that. NLP also has as a child the way that deep learning sits in machine learning. NLU sits in NLP, but NLU is also distinct from NLP. NLU stands for natural language understanding, and within natural language understanding, we have key concepts such as relation, extraction, paraphrasing, and natural language inference, dialogue agents, which is what we call dialogue flow, the Google agent for chatbot builds. And we also have sentiment analysis, summarization, question and answer, question answering QA, and semantic parsing. So we'll come to that, but let's attempt to finish our use case diagram. So what do I really mean by all of that? Well, let me explain. So I have made a copy of this, and what I'm trying to say is, as part of natural language processing, we must understand natural language. Yeah? Natural language is included in the facilitation of natural language. Natural language understanding, NLU, it's included in the attempt to facilitate natural language processing. And I want to relate them. You can see the line I have used here. It's called an includes line. Look at that. I love VISIO. VISIO is the best tool. I honestly recommend that you get this. Smart Draw is always it's always very finicky. Lucid Chart is good, but not as good as VISIO. VISIO I still think of as the daddy of all tools. So if we look at that, we can see that there's a strange, odd take that to 12, that's it. Send to that, that's it. So you can see an arrowhead. The association line hasn't got an arrowhead, but the includes line has an arrowhead. You can see that there's a relationship. So I've planted that there, planted that there. That line goes from the including to the included, meaning that this does not stand by itself, but as a result of facilitating natural language processing. Yeah? Another thing to do is to just make this more complete. I'm going to make this more complete. I'm going to delete a few things here. So that we can design in peace. And when you do the use case diagram, you try not to let the lines cross. One of the ways that you can quickly establish whether the work you've done is good or not is when you see that the lines are not crossing. So you can see that the lines are not crossing. I'm doing my best to avoid that. For readability purposes, it's not good. For syntactic purposes, it's not good. Imagine presenting to somebody who doesn't know what a use case diagram is all about, and you have crisscrossing lines. You would only confuse them. And remember, the whole idea is to make life easier for these people, not to make life difficult for them. I need this actor here. That's why I don't want to delete that. But the next thing to do is to also put the next use case. It's also an includes, and it's classifying natural language. Yeah. This is supposed to be natural language understanding, but I did not like the phraseology. Remember, I said the protocol for naming use cases has to be verb first. That's why I changed that. This says classify natural language, which is good. It's also another includes line. It's also reused. It can also be reused. Yeah? So... can also be reused, and that's also an includes relationship. Let's carry on. Another thing that you do is that you generate natural language. It's called natural language generation, NLG. But the phraseology, I did not like that. From a use case protocol point of view, it must be verb first. That's why I've changed that. So here, you see includes. Yeah. And also... there is the facilitation of facilitate machine perception, which is getting the machine to understand the human speech. So I hope this is getting clear. The next and the last item is that this user story, manage human computer dialogue systems. Manage human computer dialogue. Yeah, so let's manage human computer dialogue. It's another U, includes relationship. Oh, Visio is so good, and every time that you use this tool, it gets better and better and better. Here is a system actor. We are just simply going to call this NLP Frameworks. Yeah, it could be NLP tools. It could be NLP libraries. It could be NLP systems. I've deliberately put all four there. You're not obligated to use all four. This is for the purposes of getting you to understand the different ways that you can name the secondary actor. So if I had just called it the NLP frameworks, that would have been enough. Now, I want to explore a little here. When we talk about frameworks, what do we really mean? When we talk about frameworks, what are we trying to say? What are the natural language frameworks and toolings and algorithms that make it possible for natural learning language to happen? What makes it possible? What are the range of models? What are those systems made of? It's got to be pretty special because these systems are in charge of the understanding. They are in charge of the natural language generation. They are in charge of the natural language generation. They are in charge of the machine perception. They are in charge of managing human-computer dialogue. So when we talk about systems, what are we talking about? How does it work? I want to just quickly show you a diagram here. So, Xenon stack. I want to show you a diagram. Beautiful diagram that tells the story of the architecture of natural language processing. That's it. It's a beautiful picture. Look at that diagram. Basically, this is NLP architecture. The fact that the human speaks or the human writes, the file comes in, there is the natural language detection ability of the machine. So it can detect English, it can detect Spanish, it can detect Arabic, it can detect French, it can detect Swahili. All sorts of languages are detected. And depending on what is detected, English has rules about the English language. So the words are tokenized, broken up. So when you have it is a dog, it is broken up, separated from is broken up, separated from it and A is broken up and separated away from S and dog, and then dog, it stands by itself. So the words are tokenized, chunked up, biticized, broken up into pieces, so that in the context of the English language, pre-processing means that the rules of the language is applied. Tokenization for Spanish would also tokenize so that the machine, natural language processing machine, can pre-process the language detected according to the rules of the Spanish language. And the same thing for Arabic, and the same thing for French, and the same thing for all others. After the language has been detected, and after the file has come in, after the file has been ingested, after the file has been, the machine has detected the language and split it according to the necessary pre-processing rules for each language type. The next process is to do the modeling. So according to each language, again, future extraction. There's a future extraction. All sorts of modelings and algorithms are applied here. And once that process of modeling takes place after the pre-processing, this is where the actual natural language processing takes place. Once that has taken place, then, ladies and gentlemen, is the big one. What happens? We now see, and I want to show you something else here. If we go to the top of this, you can begin to see the different usages, which essentially is the output. So that pre-processed and modeled language can then be used for classification, can then be used for translation, can then be used for topic modeling, can then be used for entity extraction. You can now go ahead and perform sentiment analysis. You can now go ahead and perform intent analysis. You can now go ahead and perform utterance analysis on the output. So this is the architecture that natural language processing follows. If we go back to our use case diagram, when we talk about, you can begin to see the nature of this includes relationship. You can begin to see what it means. So as I said, includes talks about include means that must be used to achieve that. That must be used to achieve that. As part of modeling, the machine must understand the language. As part of classifying the language, as part of facilitating natural language processing, the machine must classify the natural language. As part of modeling the natural language, the machine must be able to generate its own natural language, or its own way of understanding the human language. As part of modeling, the machine must be able to facilitate machine perception. As part of the modeling, as part of facilitating natural language processing, the machine must be able to manage human-computer dialogue. All of this must be possible as the natural language processing domain attempts to realize this use case of facilitating natural language processing. So these tools and these frameworks make it possible. These are the tools, these are the algorithms, these are the various deep learning and machine learning. Remember the diagram, deep learning diagram and machine learning diagram. Those are the algorithms that make the output possible right here. Yeah? What I'm going to do is I'm just going to leave a note. Okay, in within UML or within Visio, within all diagramming tools, there is a concept of the note, and we use that to just annotate the diagram. We use that to annotate the diagram. So that people reading it can read it in context. So what I'm going to do is just annotate the diagram so that anybody reading it can have a look and see that what I mean here are the algorithms. So in our internship series, what we will do is teach you about those algorithms, teach you about how, and you have hands-on experience, you detect fake news, you are able to use machine learning libraries to be able to work on real life projects with us, and see how this would work in machine speak. So you've come here. We have now got a use case diagram specific to natural language processing. We have achieved that objective, I'm very happy to say. So I would aim to also repeat this for all other instances of, I want to rename this, that's it. So NLP UCD, that's it. Yeah, that's it. So you can begin to see how this works. So once you attend our internship session, it's a fantastic opportunity to be able to come and absolutely for 10 days, for 20 days, get immersed in the language of the domain. Come and be baptized. That word just came to me. Come and be baptized in the language of artificial intelligence. So once again, my name is Dr. Sandra Powers. Connect to me on LinkedIn. Connect to me on Facebook. Connect to me on Instagram. Connect to me on YouTube, connect to me on other social media channels, and also reach me so I can send you a link to our Telegram group. We have a consumer messaging apps group called Telegram, where we manage the affairs of you, the customer. You know, you are only a chat away from us, and you're able to see what the latest offers are, what the latest news pieces are. You are able to see what the latest courses are. You are able to see what the latest propositions are. You're able to get tips for your interviews. You're able to get instant alerts and notifications on the latest videos. Oh, that's a spelling error. On the latest videos, so you don't miss out on anything. So thank you very much for being with us. Thank you. I hope you have enjoyed the session. I certainly have, and I shall see you next time. Thank you so much. Bye-bye for now.